Hello, and welcome to the Conservation of Energy Roller Coaster video tutorial. Here we have a roller coaster car up at point W. It's going to come down the track, go through point X, past point Y to point Z and on. And we are solving for the velocity of the roller coaster car at point Y. Point Y is 10 meters high, the car starts at 30 meters high. With any of these problems, the first thing to do is an energy bar graph. So here it is down here set up, and we've got our energy bar graph for W, which is our starting point, and for Y, our ending point. We'll go ahead and fill this in now. When the car is at point W, there is no velocity, so there's no kinetic energy. It's pretty high up, so it definitely has gravitational potential energy. It's not compressing a spring or anything of that nature, so there's no elastic energy. And unless stated in the problem, there's no friction in the track, and we're going to ignore air resistance, which means we're not going to deal with internal energy. So at the top, it's all gravitational potential energy, so we'll go ahead and show that. So about 3 bars of gravitational potential energy. And then once it reaches Y, it still has height. It has 1/3 the amount of height it had originally, so let's give it 1/3 the amount of gravitational potential energy that it had previously. Alright. Now, it used to have 3 bars of energy and now only has 1 bar of energy, but conservation of energy states that the energy can't be created or destroyed. It has to just change form. So the missing 2 bars must be the motion of the car at this time, because if you look at point Y, still there's no springs or any elastic elements and no friction or air resistance. We're ignoring this. There's 2 bars of kinetic energy at this time. There's no discussion of energy leaving or entering the system of any kind, so we're just going to go ahead and say that Q equals 0, which represents no energy into our system from outside sources, and also no energy out of the system to outside sources. Alright, so we're going to use this energy bar graph to make our equation. So we're going to start with, we had gravitational potential energy to start, and that is mass times gravity times height, and that is going to equal, well, we have 2 types of energy over here. We have kinetic energy, so that's 1/2 mv squared, and we also have some gravitational potential energy left over, so that's going to be mgh again. We need to denote that these 2 h's are not the same. The height here is 30 and the height here is 10, so we're going to call this h1 and lowercase m for mass, and we're going to call this h2 to represent that these heights are not equal to each other. Next thing to do is we're going to go ahead and we're going to compress this together so it reads a little smoother. So we'll just bring the equal sign over, and there. So here's the conservation of energy equation that we're going to work off of. The first thing you might notice is that you don't actually have a mass given in the problem. Nowhere up here to tell you the mass of the cart, but you don't actually need it. If you look, you'll see that there is a mass in every term in both sides of the equation. So those are going to nicely cancel out. So we can rewrite this without the mass. So gh1 is equal to 1/2 v squared plus gh2 space there. Alright. Next thing we're going to do is we're just keep working on this and trying to get the velocity by itself. So what we're going to do is we're going to subtract this term from both sides, and once this comes over, we're going to multiply both sides by 2. So v squared is equal to gh1 minus gh2. So that was bringing this over, and now we want to multiply both sides by 2. So we'll just do that in front. Alright, so this is just doing algebra from this down to here. All right, now we're going to do two steps at once. First, we're going to bring the g out of the parentheses because everything in here has a g, and then we're going to square root both sides to get the velocity by itself. So velocity equals the square root of 2g h1 minus h2. All right, and there's your equation for the velocity. Now we're just going to plug in our values to our simplified equation. So 2 times 9.8. h1 is this height, so that's 30. And h2 is this height, so that's 10. All right. So 30 minus 10 is 20, so we're going to multiply 20 times 9.8 times 2. So v is going to equal the square root of 2 times 20 times 9.8, and that's 392. And the square root of 392 is 19.8 meters per second. Thank you for watching the Conservation of Energy roller coaster video tutorial.